This is the rest of your Lesson 2 homework. So questions 9 through 12 ask you to write the equation in the form y equals k over x. So they already look like they're pretty much in k over x, but what it wants is nothing inside of the denominator except for x. So what we're going to do is we're going to take the numbers that are attached to it and turn those into decimals. So 2/5 is really 0.4. So this gives you y equals 0.4 over x. And that's all that it's asking you to do. Nothing harder than that. We don't usually work in decimals, but in this case we are. Same thing here. 9/2 is negative 4.5. So y equals negative 4.5 over x. Going on to number 11, it's already solved for you in terms of not having a fraction, but you need to get the x over to the other side, so y is by itself. Well, to do that, you need to divide. So 7 divided by x. And then on number 12, this is 2 parts, but neither of them are overly difficult. I need to get rid of these 2 to get the y by itself. So negative 3 over 2x. Well, now I need to simplify these numbers, and that's really just going to give me negative 1.5 over x as my equation. Okay, so the equations are pretty simple. Now onto the graphs of these. So when you're making a graph of these, first I have to solve them. This little blue dot's bothering me. So I have to solve them first. So to solve this one for y, I get negative 3 over x. Okay, so now I need to go for my asymptotes. So in terms of asymptotes, that has to do with my domain and range. So I say, all right, what values can I not plug in for x? Well, I can't plug in 0 because that would make it undefined. Because if you do negative 3 over 0, that's undefined. So what that tells me is at x equals 0, I'm going to have an asymptote. Okay, so x equals 0 is going to be my vertical asymptote going up and down. So then let's say I rearrange this problem and I go back to the top and I'm solving it for x this time. And I get x equals negative 3 over y. Well, what numbers could you not plug in for y? You couldn't plug in 0. So that's going to put an asymptote going this way. So now, because you can't find an x or a y intercept, what you need to do is make a table. Because anytime you can't find an intercept, you have to make a table. So because this is negative, we're going to be working in quadrant 2 and quadrant 4. So with my equation, I'm going to try and put in as many nice numbers as I can. So I usually like to go with a half. So if you put in 1/2, you get negative 3 divided by 1/2, which is really negative 3 times 2. So that's going to give me a negative 6. So over a half and down 6. So my next nice number would be to put in 1. So negative 3 divided by 1 is negative 3 over 1 and down 3. Then I would probably put in 3 because that's a nice number. So negative 3 divided by negative 3 is going to give me a negative 1. So over 3 and down 1. And then, just to keep everything consistent, I would put in 6. Because when I put 6 in, I would get negative 1/2 back. Okay, so here's the first part of my graph. So this is quadrant 4. Okay, I need to reflect it up to quadrant 2. Well, in quadrant 2, if you think about it, what happens there is you're going backwards on the x-axis, so you're making your x's have to be negative. So I need a negative x, and my y's are going to stay positive because I'm going up. So I'm flip-flopping both of these, really. 1/2 and 6, negative 1, 3, negative 3, 1, and negative 6, 1/2. And then I'm going to plot those also. So 1/2 and 6, negative 1 and 3, negative 3 and 1, and negative 6.5. Okay, so there's both parts of my graph. Next one, same thing here as we need to solve this one. So the first thing I need to do is move this 2 to the other side. So I get x, y equals 2. Solve this for y, and I get 2 over x. So what I know here is that I'm going to have asymptotes at 0 and 0 again. Because I can't plug in anything for x, I could plug anything in that's not 0. So my asymptote is going to be at 0. That's the only thing I could plug in the bottom that would make it undefined. Any other number I put in would not be undefined. So then if I solved this and flipped it around, I couldn't put in 0 for y. It would make it undefined. So that's my other asymptote. Okay. So then I want to make a table for this because I can't find intercepts. When you can't find intercepts, you need to make a table. So what I know from this is a positive equation, so I'm going to be working in quadrant 1 and quadrant 3, which are these two. So I'm going to plug in things that nicely divide by 2. So I'm going to start with a half, because 2 divided by 1/2 is really 2 times 2. So I get back 4. So over a half, up 4. Then I would put in 1 and get back 2. Plug in 2, get back 1. And then 4 and get back 1/2. Okay, so here is my quadrant 1 graph of this. So then I know it has to be in quadrant 3. So I have to think about, what do I do with the points in quadrant 3? Well, I'm going back on the x-axis, making it a negative x. I'm going down on the y-axis, negative y. Okay, so I'm just flip-flopping both of these. Negative, negative, all the way down. And graphing those. So back a half, down 4. Back 1, down 2. 2 down 1, 4.5. And there is that one. Okay, so I'm going to skip the next two so I can get to these story problems, because I only have 10 minutes because I haven't upgraded. So you found a house to rent near you in the university. You invite 3 friends to share with you. The amount of rent is based on the people that live there, obviously. So if the rent per month per student is related to this equation, the rent is 2,100 over n. Okay, so rent is 2,100 over the number of people. So find the monthly rent. So n is the number of people. Well, they told you that you have 3 people living with you. So all you're doing is dividing this by 3. So your rent then is $700 per person. So if you want to make this much more reasonable and live at $350, so my rent would need to be $350. I still have to pay that entire amount, but I want to know the number of people that would have to live with me. So what I need to do now is flip-flop these two. So I get 2,100 over 350. So when you do that, 2,100 divided by 350 is 6. So 6 people need to live with you. That's a lot of people. 6 people would have to live with you in order to have that be your cost. Okay, the frequency f in hertz of the sound wave varies inversely with the wavelength w. The function is given to you, models the relationship. So the end question says, find the wavelength. Well, the wavelength is w, so we know that we're still going to have 356 over w, when the frequency is 520. Well, we know that if we want to solve for w, we're really moving it to the other side. And then dividing by 520, or we're just flip-flopping. Okay, so we're just flip-flopping those. So W equals 356 divided by 520. So my wavelength for this is going to be 0.684. And I have no idea what the label is because I don't know wavelengths. The prom committee is buying souvenirs for the junior-senior prom. The price of each souvenir is inversely proportional to the number of souvenirs purchased. The equation looks like that. Okay, so the prices and the students, that's what our variables are. So if the committee buys 375 souvenirs, which is our S, souvenirs is our S. I think I just said students. I didn't mean that. What is the price for each? So I say, okay, price equals 3,200 divided by 375. So when you do that, you're going to get the price equals $8.53 each. So each souvenir that they buy for the prom is $8.53. So if they find a souvenir for $4.55, how many can they purchase? Okay, so they have $3,200 altogether. So we're going to take that, 3,200 over S is how many souvenirs. So remember, we can flip-flop these. Souvenirs is 3,200 divided by 4.55. So 3,200 divided by 4.55 gives us 703. So I have 30 seconds left to quickly tell you this last one. They want 432 students to attend. So 3,200 divided by 432. That's going to give me a price of $7.40 per souvenir.